People can't hear me. People can now hear me, I think. Thank you for that, Minxie Rose. Yeah, I'm forgetting how to set OBS up. So I will say it again. Thank you to the lovely people at bensound.com for the music. If you type !music in chat, you will be able to get a link to their site. So, once I've sorted myself out, apologies for that. Last week we built ourselves, well, we were trying to build a calculator and we didn't get there, and we won't get there for a few weeks yet. But what we did do is, if I kill out certain things here, because there's something there I want to keep. Wow, I really haven't done everything I needed to do. Okay, I thought I was ahead of time. Obviously, it appears that I'm not. Get rid of that as well. So we did the following. If we go back to this screen, we learned about Open System and the fact that that is what we use to get to things that are provided for us by F#. We can open other namespaces up as well, but that one is just the system one. We worked out that the entry point came from F# itself. That tells the compiler this is where we want to start running our program. The word main there means nothing. As far as F# is concerned, that could be Bob, because Bob is very acceptable. And if I go into the correct place and then do .NET run, you will see that this still works. Can I not bump the terminal font up in here? I must be able to. While this is waiting to do stuff, let me see if I can bump up the terminal font, because that is too small. Markdown preview, terminal font size. Yeah, let's get that up to 22. Cool. That now asks me what my name is. I type in Gareth, and it says hello to me. So the fact that that is Bob, that doesn't matter. We just call it main out of convention. This argv we've never really looked at, and to be honest, I'm not sure that we will for a short while. It's called argv by tradition again. It could be called Steve. It could be called anything. Normally, I tend to call it args, just because I don't really like the C tradition there. However, we'll stick with argv. We learnt that printfn is a function, and it can take a variable number of arguments. The first argument being, what is your name? In this case, it being the format string. We had a brief look into format specifiers and how to make print our variables rather than just printing something we tell it to. And we had a look at console.readline and the fact that that being a .NET class method instead of a function in F#, it has to be called slightly differently. That's just a brief overview. Now, for everyone, I posted a link in either chat or the Nightbot did it for me because Nightbot is lovely. We had links up on Twitter in the Discord pointing you to this file. So if you open the link up, you will get to here. We click on this download button up there. Let me do something up here. Yeah. So if we click on this button here, it downloads. So let's do that. Nightbot mean. Why does Nightbot mean this time, Minxie? So it asks us what we want to do with the file. We're going to save it. View our downloads. And no, I didn't want to view the downloads, did I? I wanted to get to our downloads folder so that we can right click, go properties, and unblock. This is important. This is very important. You want to tick in there, then apply and OK. If you don't do that, things will moan. Then we extract that to wherever. And then if you're using Visual Studio Code, you go into Calculator, Calculator again, because that SLM file is really for people using Visual Studio itself. In fact, I will quit Visual Studio Code, will work in this version of it. Just to prove that I'm doing this properly. Right click in there, open with code. If you set Visual Studio Code up to do that, that will work. Otherwise, click in there and copy it. Open up code however you like. I just hit the Windows key, type code. That will open up. And then once that's open, we will go to File, Open Folder, or we'll just go Control-K, Control-O, I think. No, that's just done weird things. Okay, Control-K-O. And go into our Downloads folder, into Calculator, and into Calculator again. And apparently again. So, as deep as calculators you can go. It's not turtles all the way down, don't worry. Having opened that up, we can have program.fs, which is our program. So that's a very brief overview on opening a project up in Visual Studio Code and on making sure that we're all in the right place. This now means that we should have Visual Studio Code up with this code in it. Your screen, it probably won't be as big as it is on mine, purely because I wanted to make sure that everyone could see even at lower bandwidths. So if the video goes blocky, it should still be viewable, I hope. Let me just check to see if we are one of the lucky ones. Not yet. Okay. And Control and the single quote key brings up your terminal. Again, your terminal will look different to this. Also, F# Interactive, again, you've probably got smaller fonts on your computer. I'm just using big ones for that reason. So, I thought we'd done more work than this. I know we went into... no, we did this in F# Interactive. We looked at partial application and functions. So let's have a look. I'm actually not convinced that this is the latest code. I think we did more. Anyway, let's change this. We want to add two numbers. So if we ask our user to input a number, input a number. Yeah, we did lots more, didn't we? I know what I'm going to do. I am going to go, because this is a lot further back than we were. Let me go fire up Discord, because I think I put a copy of the code in there. So let's go and have a little grab of that code, which is a good point. I now need to remember where I put it. Yes, we did, didn't we, Minxie Rose? And if we have a look, that is actually the code from last time. So my apologies, you probably won't have the starting code. How do I get this to everyone quickly? Let me quickly, for those not in the Discord, which if Minxie is really nice to us all, Minxie might put a link into the Discord, I'm going to create a GitHub gist quickly with that code in. Yeah, there we are. Thank you for Minxie. And Fuel Snable, that's literally what I've just... We've just had exactly the same idea. I just need to sign in quickly and see which of my million passwords I used for GitHub. Not that one. Did I use that one? Did I use that one? Hang on, I've just realised what I did. I need to use LastPass because I was clever and did the decent thing and used a random password. However, while we're going through this, we did a few different things. We did look at functions. We looked at how to turn, how to sort of work with cast into floats. That's not actually a cast, I don't think. I think that's more of a conversion. Yeah, it's direct conversion, or for a string, it's double dot parse. And we were going to start looking at error handling today, I believe. Let me just... Apologies for this, folks. I thought I'd done something really, really good and got myself all set up, and I was wrong. So if I quickly grab everything here... welcome to the stream, Brendonius. Sorry, I haven't been following. If everyone could welcome Brendonius to the stream, please and thank you. Same for Fuel Snable. I think we should really be... I should remember to welcome everyone to the stream. Wow, I've got to do other things as well. Loving the emotes, Brendonius. Loving them indeed. I've got to... Wow, I've got all sorts of things I have to do here. Which authenticator did I use for GitHub? That one. Did I get it in time? Did I get this in time? It's always the fun. Right, I did get that in time. Yeah, Brendonius, I completely agree with you that it's always a good idea to welcome people in stream. Thank you for your lurks. Unfortunately, I don't see, and I don't know why I don't, but I don't seem to see who's in the stream and lurking. And even if people are only lurking, I really don't want to... I don't want to call people out. I also can't seem to type. So let's have that as a... let's make it a public gist. Why not? So, if people want to, let me grab this and get it into chat. Wow, this is completely going to pot. I'm sure this stream was supposed to go better. There we go. If I drop that into chat, the link that's there now is the code that I have on my screen. Right, unprofessionality out of the way. I don't know if everyone was here on the Tuesday stream because I know we're slightly different targets. So just to, I really want to thank everybody. We have now got affiliate on here, so thank you to the whole community. You are wonderful, wonderful, wonderful people, and this would not have happened without everyone. So, oh, and by the way, can we give, let me give a shout out now. He's not under Brendonius, I don't believe. So, if I shout out a stream that I really like, Twitch TV Dev Chatter, you get some fantastic content on there, mainly C# development. He's done some... Well, in fact, I've pretty much nicked the beginner's idea from him. So, sorry, Brendonius, if you kind of didn't want that to happen. But we also kind of do some on-stream projects as well on Sundays, Tuesdays, and I'm hoping to stream more evenings in the week at some point. Thank you very much, Minxie Rose. Thank you, Brendonius. I am so glad that you're not upset by the idea that I've basically stolen your idea. And thank you for promoting dev streams. You do a fantastic job at that. Anyway, I do believe we have something in hand whereby we actually have something resembling a calculator. So we've got a simple F# function that's add AB, adds A and B. That goes from a float to a float to a float. And the reason that is not just takes to float and returns a float, as we discussed last week, was partial application. We have, thank you very, very much for the bits, Brendonius. If everyone can thank Brendonius in chat, please and thank you. Bits work! I think I'm pointing the right way. I hope I was. And thank you for that hype as well, Brendonius. Really, really nice to see. So, I pointed the correct way. Yes, I'm learning how to stream. One day I will make this somewhere near. And thank you for the high fives, Minxie Rose, as well. So we've got the partial application. We learned that that's why we have that notation for a function signature. We also looked at this printf.textWriter format, and that is a format string. The reason that this one takes unit is we don't actually bother with a format string in either of these. So if we had put someone's name in and put a format specifier there, then this wouldn't take unit, this would take a type. This is how the F# compiler can tell us if we're using the wrong format specifiers or if we're passing something like printf the wrong number of arguments. Really, really handy to do. And a very, very clever trick, and it spits out a float. So what does this do? Spits out a prompt, asks the user for some text input, and converts that to a float. And then at the end of the whole thing, it grabs two numbers, adds them together, and we have the format specifiers to print them out. Apologies for that. I'm remembering to hold that button down. This is good. So we're left with a little bit of a conundrum, if I recall correctly. If I run this, and we wait whilst I drink some coffee, because obviously developer, let's turn coffee into code. And it's asking what my name is. Why is it so? Let's come out of that and do a build. Oh, because I was a fool and forgot to save the file once I'd copied the new code in. If we do a .NET run again, we're actually running this program and not the program that we were showing from the last stream. So let's run it. It's built up, so it's asking for a number, as we can see in the code. I'm going to put 12, it's asking for another, I'm going to say 30, and it says that the answer is 42. However, I am a user that I don't like using the number keys on my keyboard. I'd rather say 3. And it goes bang. We have an unhandled exception, which means something's gone wrong and we are not dealing with it. Now it's saying system.format exception, input string was not in a correct format. So this is F# saying, I wanted a number. You've been mean and not given me a number, because it doesn't recognise that that is a number. It sees that as just text. And then it gives what's called a stat trace, which is, how do I explain this? Let's not look at this stat trace for the moment, but let's have a look at what we're doing. So this calls ask for float. So main calls ask for float, which calls printfn. So we've got to, the compiler, the runtime has got to remember where to go back to once it's done that. So it does the printfn, it calls that, and then comes back to ask for float. Once ask for float's done everything it needs to do, it comes back to the main. So it digs in and then pulls itself out. A stack trace is a way of saying this is where the error occurred and this is what called it all the way up. So system.number.parseDouble. That's the actual method that's called in .NET. We didn't call that, did we? So did we call system.double.parse? Because that's what called parseDouble. We probably didn't, but I think we probably did in a way. Because then it says at program.ask for float. Now we know that. Because we are in program, this is program.fs, and we wrote ask for float. However, where's the call to system.double.parse? Well, that would be in float itself. So what we're saying is, this is where we went bang, and in fact to prove it, I'll stick a breakpoint there. So go into the gutter, and there. And then, we then need to go into our debug and go here. ANTW Games, hi, and thank you for the lovely words. Welcome back to the stream. If everyone could welcome ANTW Games, please and thank you. That would be a wonderful thing to do, and as we know, we are wonderful people here. Now, I believe we did this last time, the whole retrying to run this, and seeing what happened. I'm going to have to go through it very quickly again, So it'll be netcore app 2.1, and then it's going to be called calculator. So we've got that. We're not bothering with anything else there. I do believe this was covered on the last string. What are you now saying? Now configure that task. .NET Core. Have another go at it. And we're in the debugger. And then it says that doesn't exist. Why does that not exist? Do bear with for a moment, please. It's done. It's NetCore App 2.1 these days. Okay. This I believe, like I say, we covered in the last stream, so I don't want to go over too much old ground. I think there is one more thing I might have to do. I'm not sure. Yeah, please enter a number, and this is not going to take a number in, is it? No. Okay, so the other thing that we have to do is, as I recall, in Launch.json. Let's go up there. I've just worked out what this emote that we have needs to be. Console, what are my choices here? Because I know that this is where we had a problem. And let's say integrated terminal instead of that console-y one. We need a shambles emote, don't we? That is the overarching theme of what we need. Let's go back into the debug thing and click run. So it goes to the debug console. We want the terminal. We're going to enter a number. Let's enter the wrong one. Let's enter that 3 again. And yeah, so it got all the way to text input. We've got text input. If we hover over it, it tells us what it is. And then we've broke on this line. We have variables there as well that tell us what we've got in scope. If I try and step into that, that's exactly where it goes bang with that identical same stat trace. So that shows that we go bang there. And if I stick this launch.json in a gist as well, and I will stick the contents of, so that'd be launch.json. And if I stuff the other one in as well, hang on, no, I've clicked the wrong button here and my machine's deciding not to play. For those that were with us last week, you've all got this. Anyway. Why is my... Okay. Let's... where are we going now? Launch.json, which will create it public again. So the launch.json is that gist. There's also a tasks.json, which will stuff in another gist. New gist. Tasks.json. And it will be that I'm about to post in chat once I get around to remembering keyboard shortcuts. So those go in the .vs code folder. If you just ask VS Code to create everything for you, then just copy in what we've got. You'll get exactly what we need. The tasks.json one is stock .NET build, .NET Core. So let's, with that, and obviously if you have any problems, post in here please, or drop us a message in the Discord, and there are people waiting to help, and I believe that people are really good in here and we do help each other. Now this isn't that, actually let's not do that, let's go. We now have an issue. we have to sort this exception out. Yeah, we have that in there. Oh, by the way, welcome to the Discord, ANTW Games. Seeing as I saw it there, I'll shout it out. So thank you, welcome to the Discord, welcome to our dev home. We've got to guard that float text input. We've got to say, well, what are we going to do? Now you feel like you're being watched. Now you know how I feel doing this. No, it literally flashed up, so I'll give you the thank you on stream. I will be nice. So we've got to guard against this text input. We've got to say, whoa, what happens if this isn't actually a number? Well, we have methods, instead of just calling float, because that will go bang if it goes wrong, we can do something slightly different. We can do a try parse on it. So we can go float, well, let's go for a double precision, because that's what float in F# is. Or is there something more interesting? No, there isn't. So we can go double dot try parse and pass in our text input. Now, in something like C#, that we would have to also pass in a Boolean type, a true or false type, to that we don't care what it is when it goes in, and we'd have to read it out. That's for the benefit of the C# programmers. Here, we don't do that in F#. We actually get that out as a tuple. So we can say success, comma, value equals that. And of course, we have to let that happen. So before we go any further, and yes, that let is now going to throw an error. We're not bothered about that yet. But let's have a look at what we've just done quite closely. We have, let me go into Inky Ink mode, because Inky Ink mode is good, and it means I can draw on the screen. See if I can remember how to do this on here. So we have asked, instead of letting a single value, we've got these brackets and a comma. So we've got that, and that. And we have two things. We have a success and a value there. So that is true or false. That success is true, false. And that value is what we got. So the number. And normally we could just do, so instead of that, we could do something else like let the tuple equal that double dot try parse. We're not doing that, we're destructuring the tuple. So that double dot try parse spits out something like a tuple. It will spit out, I don't know, true and the number 3. And we can stick that just in one value, so we can go let answer equal that. And then we can go the first answer or the second answer. So instead of doing that, we're just shortcutting that process. ANTW Games, are there video recordings on YouTube or somewhere else? Yes, there are. This is only once per week for the Complete Beginner stream. And after watching me for a few minutes, this will be perfect for someone new to programming, while most F# learning resources that you know of are more suited to programmers, especially C# programmers. Thank you very much, ANTW Games. That's exactly where I'm aiming. How this came about, just for a quick moment. This whole thing came about because I wanted to... my partner, Minxie Rose, in chat, who's now probably rather embarrassed, wanted to learn programming, and I wanted to show her something like F# or something functional. given that she doesn't know object-oriented programming, I thought something like a functional language would be nice to get started with. And get used to the functional concepts first, rather than having to make that jump, rather than having to go from OO to functional. And as you say there, ANTW Games, I don't see any resources out there. I'm sure they are out there, but I can't find any. So these streams are getting archived to YouTube after a day or two. And hopefully then people will be able to learn from them, again, learn in the Discord with us all. And really, I'd like to get people up to speed with F# and with programming to the point where everyone can follow along with the Sunday and Tuesday streams where we build our Stream Deck replacement. And by the way, I'm calling this a Stream Deck replacement. This eventually will do things that a Stream Deck, because it has buttons, can't do. We will be making use of the touchscreen interface a lot more than we do at the moment. Well, let's get back to it. We have a success, which is a Boolean, and a value, which is a float. Okay, that's cool. Because that then means we can see if we succeeded or not. It won't go bang. For now, let's just return the value. And if it's a none, it's not going to moan too much. So if we run that up in the debugger, sorry, I tried to do something smart there and failed. No worries, ANTW Games. If everyone can say goodnight in the chat to ANTW Games, thank you very much. That would be much appreciated, please. Yeah, thank you very much. Enjoy yourself. So anyway, we're going to go up into debug in Visual Studio Code, which is this no symbol over a bug, and then click play. We'll give that a moment or two to run up. Hi S&B, just got back from the Safari Park, ready for F#. That's excellent, S&B. We have a few gist links for the code that we have. I believe you're in the Discord, aren't you? If you haven't got the code from last week, if you go into the Discord, into Friday Fundamentals General, in fact, I'll bring that up now, scroll all the way up, and we're working with that code from the stream. The thing that Minxie Rose has linked to, unfortunately, isn't the project we were working on the stream. So what I could do is, actually, when we have the break, I am going to re-upload that project and make Nightbot point to the right place. I'm going to upload where we're at once we get to the break. I think that seems reasonable. So let's go back to our terminal, because we're set up to run in there. And it's asking for a number. Well, if I put 12 in, it's fine. If I put 3 as text, it just treats that as a 0. So what we've done is a very, very limited guard against people not entering numbers. It seems a little bit bad though for user experience, that does, because we're not telling the user what we're doing. We're just saying that that's a 0, let's carry on. That seems a little bit unintuitive to me. So let's say I'm not going to go into parsing words as numbers. I don't think that's reasonable to do. So let's instead tell the user if they don't, then we're not going to accept their input. So for this, we are going to introduce a new concept called pattern matching. And what this is a very, very powerful way of getting us the right values that we want, and letting us, instead of using an if statement, say, we get to match things. So let's, I think the best way to explain this is with some example. If we match the success value with And now under here we go for the pipe character. And what are we saying that success is? Well, if we're saying it's true, then we're going to return that value. Yeah? So that match expression returns whatever is there. So if we succeed, we're going to return that value. However, as you can see, Visual Studio Code has been lovely and highlighting success with a green highlight. So let's have a look at what the green underline is telling us. It's saying incomplete pattern matches on this expression. For example, the value false may indicate a case not covered by the patterns. This is F# saying to us, you've covered the case where this is true, but this could be false. Would you please, ever so kindly, do something about that? Well, that's great. Let's do something about false. And now, what are we going to return? What are we going to do if it's false? Now, a first thing that I would suggest is let's tell the user that their input was bad. So go, I'm sorry, but I can't understand you. Okay, that's handy. Problem. This expression was expected to have type float, but here has type unit. Now it's ink time again, I think. I think we need to go into the sketchpad. Let's get rid of everything that we had last time and look at that match expression. So what we're saying is if we're going to do match... Whoa, I really am struggling today. Let's have another go. Match something S with everything here, as we know, true, false, has to have the same type. So that is all of the values that S can be. But over here, if that's going to be what we're calling a float, or a floating point type, then here we must have a float. Because what we can do is assign the result of this expression to something, let's say X for now. So that is an expression. Once you've done that, you get a value out. And it must be the same type. So you can't do nothing there. You can't just return unit. You can't return that. That does not work. So pattern matching is a little nuanced, but is something that is pretty easy to get used to in F#, I think. So let's go back here. We're now saying, I'm sorry, I can't understand you. That's fine. But we then have to return, let's say we return a 0. And again, in brackets for that, print fn, and that is type int. Okay, do we remember why that's an integer and why that's not a float? It's a 0. It's a number. To save us being quiet for too long, as I don't have any thinking music, we have to tell F# its floating point value by giving it the decimal point. That is very important. Yeah, there we are. Minxie Rose got it. Minxie Rose caught it in the chat. So, what have we done? Well, if we debug into this again, save the file and hit run. If I enter an actual number in, I believe it will behave fine. If I don't, then I think it'll do similar to what it did last time, but I would say that it would tell us that it doesn't understand. And it does. It does, however, though, still assume that we've put in a 0. And that's reasonable, because we have put a 0 in. So, excellent. We have what we wanted there. However, this isn't very F-sharpy. There are a couple of things that are not particularly F-sharpy here. S and B can we recursively call ask for float instead? We may do. That may be something that we could do. Keep badgering our user. But at the moment, we don't have... Well, we have a couple of issues. One, if we don't go down that solution, if we just say we're going to bomb out first time, 0's not a good return value because we can work with zeros. So let's do something else before we go down the recursive route. Let's say if it's false, we want to indicate that. Now, for those that know something like C#, you will be very tempted to pass a null there. Null isn't a float. And no, we're not going to use a nullable float type. We don't like them. Let's introduce ourselves to something called the option type. So if this is none, and this is some value, then we've got what's called a float option. However, we now have an issue. These are now not going to play nicely at all. So we need to work out what we're doing with options. Now, there are a few ways of doing that. One of those is we go into something called computation expressions. If there were an option computation expression pre-written, we would have a go at that. There isn't. And that could be complicated to write. So, let's for now forget the idea that we're going to do a printfn there. Let's comment that out. And let's go and do a different printfn. Let's say num1 is %a and num2 is also a %a. The this is now moaning because it wants arguments, and because we've used %a, uses the generic type A and the generic type B there, saying I can't help you with what types you're going to pass me, just pass me anything and I will deal with it. So because we're using an option type, remember that ask for float now returns a float option, it's wrapped a float up. And to demonstrate that, num1 and num2 are being passed there. So we have now something that works, but these are not floats. It says float option. So it's saying I may be a float, but I may not. We'll work it out at some point. Let's debug that. Let's have a look at where we're going. What we're doing, well, let's let this build. We'll go back from the debug console to the terminal. Please enter a number. So 12 and my canonical example of 3 are saying, I'm sorry, but I can't help you. Num1 is sum 12, num2 is null. Why is num2 null? Reason is, that's returned a none. Why has none converted to null? It shouldn't have done. So I don't understand that entirely. What I do understand is num1 %a. That's not a 12. That's sum 12. So that's a wrapped up 12. That's a 12 in another world. That null, I think, is what none turns into when it's printed out. So that's one way of dealing with things. However, S&B brought up a wonderful, wonderful point. Can we recursively call ask for float instead? I think we can. Let's have a go. Are we going to show the error? I say we still show the error. So let's, after the error, and that semicolon is just a separator, we don't have to end lines with it. We could just as easily, in fact, now that we're going to do the error showing, let's get rid of the brackets, get rid of that, and tab that in. So that's exactly the same thing. Remember, we need these columns to be in alignment. F# is all about alignment. Did I answer your question there, by the way, Minxie Rose, before we move on too much? Let's just make sure that we're all up to speed and understanding each other. This none and this some. Let's not bother with those. Let's instead say, if it's right, we'll send the value back. And if it's not a number that we want, if it's not something that we recognise, well, let's call... please ask it then, Minxie Rose. Please, please ask it. We're going to do what S&B has suggested. We're going to call ask for float. And because we're given a prompt, let's just call it with the prompt again. Now we have another problem. Unfortunately, that's not as simple as it first seemed, because ask for float says that the value or constructor ask for float is not defined. Remember, F# goes down. We have to define things in order. So it's going, right, we're in something that's called ask for float, and we're defining it here. So this is what we're defining, and this is the definition of it. Only once we have done the full definition, if we only use the, if we're trying to use it within its own definition, it hasn't been fully defined yet. So what we have to tell the compiler is, actually, anywhere within here, it's usable. And that is with this rec keyword. It's let rec. And again, hovering over it, Visual Studio Code tells us that it's used to indicate that a function is recursive. It calls itself. Cool. Minxie Rose, if they use inputs 12, if the user inputs 12.0, it's a float. If they give 12, it's an int. Normally, yes, but what we're doing is we're trying to parse that into a double. Now, int will parse into doubles. So, yeah, as S&B says, this is saying the user isn't actually entering a int, they're entering a string containing the number 12. This double try parse takes the string and spits out a success and a value. So the fact that 12 can become 12.0 is fine. Does that make a little bit more sense? Yeah. If you have any more questions about that, let me know. I'll try and explain that further. And thank you, S&B, for also helping there. That's awesome teamwork. So we've got this now. So we're saying we're going to badger the user repeatedly until they give us what we want. Okay, let's give that a go. Let's run this. If we spin this up, it's taking a short while to build. Yeah, I think I've got half an idea why. Okay, so if we go back into our terminal, we're going to enter 12 because we're good at entering 12s, and we're going to enter 3. And it says, I'm sorry I can't understand you, please enter another number. And again, the same. As soon as I back down and go, okay, I'll do as I'm told, it spits out the numbers. Now, because we'd entered 12 there, double dot try parse took in the string 12 and spat out a 12, but that is a float, so it's a 12.0. Oh my word, over there, thank you very, very much for the Visual Studio host. For anyone that knows, Visual Studio, Microsoft have their own channel on here where you can get all sorts of resources. Let's give them a quick shout out. Visual Studio. So yeah, they really do they host a lot of streamers, and they do a lot of work towards helping people out. So thank you so much for the host there. And yeah, the zombie, that's pretty much default stream tools actually, SMB. I haven't dealt with much of it. So let's carry on working a little bit on this. Unfortunately, Visual Studio hosted not long before we're about to have a break. Oh well. So for anyone that's just come in with the Visual Studio host, this is a beginner's stream to F#, intended for people who don't necessarily know any other programming languages either. So this really is quite from the start. So yeah, I mean, as Minxie Rose has suggested, instead of bullying the poor user, would it not be better to ask for numerical responses? Again, we can just go, could you please enter a numerical response? Or even, let's be slightly cleverer. I understand things like 1.0, 2.4 and 2, because it does. And I can't type things like that. However, I don't understand. And let's put it in single quotes, and let's actually tell the user what they gave us. And again, now that we've got that %s format specifier in there, all of a sudden we're getting a warning. We're getting warned that you've put a format specifier in here. If you'll be so kind, please give us the string that you want that replaced with. And we got a text input, which is a string from the user. So let's try that. Text input. And it had a capital I in it. Yes, capitalization matters. So we've told the user that we things that we understand. Let's put those in quotes as well. I mean, this is just a little bit of nicety. So pretty much the same, except now we don't run it like that. What we do is we go to the debug panel there, click start. We must remember that when we're building a debug build, we do this. There is actually an easier route to that as well. That involves a keyboard shortcut. I just don't want to bog people down with keyboard shortcuts yet. Let's again go down the whole route of, trying to keep things as simple as possible. In the terminal, please enter a number 3, and it said, I understand things like 1, 1.0, 2.4 and 2, however I don't understand 3. Please enter a number. 3, 7, and we've got 2 numbers there. Cool. So we don't need that print line anymore, and we can do the sum for the user again because we're working just with floats. And we've handled some errors. Thank you very much for the follow, THQ Inc. I don't know if the follow notification's come up yet, but if it hasn't, it's coming up across there very shortly. And at this point, I think we're not bullying the user. We've now got a way of reliably asking for a floating point value and not giving up until we've got one. So yeah, THQ Inc. has joined the fun indeed. That's cool. However, this does not a calculator make, does it? All we're doing is adding two numbers together. What happens if we want to add some more numbers? Well, we could, of course, do that. See, before we do that, this isn't finished. I do apologise. We can do something a bit cleverer. We can explain something a bit more about pattern matching. You see, we are declaring these variables anyway, success and value. And we only use the value. In that case, we don't use it anywhere else. You know when I said that we can use match as an expression, so we're returning the result of that match expression? Let's have a look at something else. Let's have a look at, instead of doing that, let's drop that in there. So we're matching that double dot try parse. Now that's not true, because it's expecting a tuple, which is what that star is, of bool and float. Okay. So we have to say that true matches with a discard. No, true matches with the value, sorry. Because if we succeeded, then the success will be true, and we are binding value there and giving value back. What I wanted to show you with this, though, is what happens here. Because if I go value there, F# doesn't mind too much about that. However, I do need to indent that in to prove it. However, we've got something there that says this value is unused. Now, we don't have the ability to just go false. So we use what's called a discard. And underscore in F# is a discard. Now, we can either use underscore or we can use underscore value. So if there's an underscore at the start, that is saying to F#, we know as programmers that this is never going to be used. Don't tell us that it's not being used. What it doesn't do is tell F# if we use this shout at us. It says this may or may not be used. However, because it isn't used there and we've already got context of what it is from up there, let's just say discard. Because that categorically, as far as I'm aware, cannot be used. So what have we done there? What we have done is got rid of a variable declaration, and we are using pattern matching with just straight tuples. THQ Inc. functional programming. Yep, that's exactly what we're going for here. Purely because there are so many benefits in my mind to functional programming, I want to kind of spread the love a little. And by the way, welcome to the stream again. I know you followed. Thank you for speaking up. If you have any questions, any comments, please drop them in the chat. Just obviously, let's be polite to each other and right with each other. Because we are a community of ladies and gentlemen, people. So there we have a recursive function that's reasonably nice. It's impure because of our reliance on the console, but we don't care. It's only a small impurity, and it's got a couple of printf ends in as well. We have to accept that impurity happens at times. That add function is still pure. That's cool. We know how to add two numbers. Do we know yet what to do if we get 4 or 5 numbers, though? Well, if we wanted 3 numbers, we could always have num3. Please enter another number. And please enter another number. So that'd be 3 then, that would be 4. And we could do 1 plus 2 plus 3 plus 4. And that's a little bit silly. We're repeating work. We're programmers in this stream. We do not like repeating work. That's more opportunities for bugs. However, if we want a variable amount of numbers, we want this add function to accept as many numbers as we want to throw in. THQ Inc., that's wonderful to say. Thank you for choosing to spend your time in here with us. trying to learn F# and hopefully getting something out of it. And also, if you guys think I'm worth it, as we've now hit affiliate status, I will plug it ever so slightly, then feel free to drop some bits in chat, as Brendonius very, very kindly did earlier on, or feel free to subscribe. If you've got an Amazon Prime account, you can subscribe for free with that. If you don't, it's normal Twitch subscription prices. Thank you very much to Minxie Rose, who was our first subscriber. So let's have a look at what we can do with add. Well, add takes 2 floats and returns just a single float. That seems rather silly, because we want it to now take a list of floats, let's say. Ooh, that's a good idea, a list of floats. How do we define that? Let's write another add function. Let's get rid of this one, because we understand it quite well, and do something else. Let's go let add. And then, what is our list of floats? What are we going to call it? Let's call it numbers. And F# not going to help us out at the moment, so let's tell it at the moment. Let's tell it for now what numbers we want. We want a float list. So we want a list of floats, which is a float list. And we are going to spit back out a float. How do we want to do this? Well, this is where we need to have a proper look at lists. Is everyone ready for a bit of a deep dive, or would we all like a break before we dive into lists? I'm happy either way. I still have coffee to drink, but we have been going for about an hour now, so if people would like to let this sink in, coffee. Okay, so what I'm going to do is get quickly back to our old add function. And then in the break, I am going to Fuel Stable's objection is completely valid. We're going to do something slightly different. We are going to do a reduction, we're just not going to use add as the function. We're gonna come at that from a different angle, I think. But yeah, we're gonna end up exactly in the same place that you've suggested there, Fuel Stable. For now, this is back to where it was. We're gonna go over that a little bit again slowly when we get back. The reason we're doing that is on the break we are also I'm gonna nip to the loo, and then I'm gonna upload the project as it stands now, so that people can grab the code and grab the whole kit and caboodle without us having issues. So I will see you in approximately, let's say, something around the region of 5 minutes. I'm back, ladies and gentlemen. Coffee's still warming up. I've still got plenty. Let's crack on. Let's not have too long before people wait. So, let's write our new add function. And what does our add function now do? It does the following. It takes a numbers as a float list. By the way, that space before that colon, neither here nor there. I don't know exactly what the real what the standard is there, but F# doesn't care. So we're going to pass it a float list, and we're going to spit back a float. So what do we do? Well, we have a few options. There are a few things lists could be. So let's go into our sketchpad again. Remove that. What could a list contain? Well, it's a list of floats, so the only thing it can do is contain a list of floats. So if the list is lists are denoted by square brackets, that denotes the empty list, square bracket, square bracket. So what do we want if it's that? Well, if the list just contains that, we need to spit out a 0. Because that is our very base case. If we're adding a single number, let's say 2, then we need, thank you so much for the subscription, SMB. That is fantastic. You're now an intern here. Yeah, that is fantastic. Thank you so much for that subscription. It's wonderful having everyone around. That kind of took me out as well. It slightly shocked me. I'm glad I've got a subscription noise on to remind me of what we're doing. So we have a single number there, 2. Well, a single number added to it, the sum of a single number is itself 2. Let's say we have 2 and, let me quickly undo because I got that a bit wrong. Let's say we have 2 and 4 in the list. And by the way, a semicolon there is how you delimit items in a list. Or it's one way of doing it. New lines is the other that I know to offhand. Well, that is 6. But how did we work that out? All we did was we said 2 plus another list. That list just contains 4. So we took the first number in that list and we said, I want that added to the rest of them. And there's only a 4 left. Well, we know that if we're adding a single number, we use that case, which is itself. So that then becomes 2 plus 4, which becomes 6. If we go for a slightly larger example, let's say we've got 2, 5, and 9. So what are we doing? We're going to say, well, let's take 2 off the front and add that to whatever is left in the list, which is a 5 and a 9. Okay, that's cool, but we've got to do this addition as well, haven't we? So we're still doing a 2 plus, and then what's there? Well, let's take the first number off the list and add it to whatever else is in the list. So add it to that list. Okay, so we know sort of what we're doing there, because we've got a 2, then we've got a 5, and then plus, well, we're only adding one number, aren't we? And we know from over here again that adding a single number is just that number itself. So that is recursive addition. And that again then comes out and says 5 plus 9 to give 14. Then add the 2 on, gives us 16, unless my maths is terrible. And that is I know that might look a bit unusual, but that is a pattern you will see often in functional programming for how to deal with lists. Is take one element and slam it into the others and keep slamming it until it's dealt with. So shall we have a look at how that looks in code? I remove the drawing apparatus. In code, that looks like, well, we had three cases, didn't we? We had to match our list of numbers with our first case we said was the empty list, and we said that the empty list is equivalent to a 0. So that means that we are dealing with all lengths of list. If we missed that out, we would get a complaint of it saying, what do you do if there's an empty list? We're saying an empty list is worth 0. We then said that if we got one number in the list, let's call it number, or just num for short, you probably understand that soon, then we'll spit out that num. And now we've got a problem. That's 0. Well, remember, floating point values, 0.0. The compiler all the way through this is helping us though. So we always want the compiler's help. So we've got that. What happens though if we've got something else? Well, we've got to learn a bit of new syntax first. And it is num :nums. You will more often see this. You'll often see in any functional language x :x's. However, and that is read as x's, just for the interesting part. However, we're going to use num because we're using numbers here. And what are we saying there? Well, that nums is a list. If I get that in there. The nums is a list of floats and num is a float. So num is that first item that was in that list. So let's say we had the list, if I just type it quickly up here. 1, 2, 3, 4. That 1 would be assigned to num, and then nums would be that. So num would be 1, nums would be 2, 3, 4. And that's what that :: operator means. And it says head and tail. If you think of it like a snake, that's, you know, it kind of works right there, I think. So we're taking that num off the list and adding it to the nums. Well, what do we do? Well, we want num to be returned, and we need to add it to something. What do we need to add it to? Well, we need to add it to the result of summing that list back up. So add numbers. And of course, that was a very good point. By the way, let's do the brackets as well. Let's go into F# Interactive for now. Ah, yes. And of course, we're recursively adding, let's call it a letrec. So let's jump across into F# Interactive. If I go there, okay, that's come up with an error for a difference. Meh, who cares? Ah, yeah. Before we go there, as Fuel Snables correctly pointed out, have a gold star, I think, if we can offer them, or, you know, a sonic ring sound. It is add nums. We don't want to add all the numbers again, otherwise we've got an infinite loop. So let's get a list in this shell. Let's use the example of 1, 2, 3, 4, which is a list of ints. So numbers equals, in fact, let's use 1.0. Let's use floats. We're using them anyway. And I'll get this reasonably neat. So we're letting numbers equal 1, 1.0, 2.0, 3.0, 4.0. So let's then print out, well, let's see what happens here. Let's let num, comma nums, Yeah, double semicolon to end once we want it to do once we want to execute it. So let nums equals hang on. Let me try and remember. We're not letting those. Yeah. Let's just let num equal head list. Let's do this simply. By THQing. Ah, yeah. Fuel Snable. Yeah, I'd forgotten this. Yeah, let's go with the Fuel Snable's example. Num double semicolon double colon nums equal numbers. I'd forgotten that you can use the double colon there as well. So we've put those in, and let's have a look. So numbers is a float list that says 1, 2, 3, 4. Nums is just 2, 3, 4. And num is 1. We can also use that same operator to stuff stuff back at the front of that list. So let's say we go 5.0 onto the front of nums. And that will say, well, it's 5, 2, 3, 4. So we can build lists up and destruct them that way. I mean, nums is now 2, 3, 4. So what do we do if we go let x is equal nums? That comes out as 2 and then 3 and 4. So what we're doing is we're just pulling the first number off the list every time on the first item. It doesn't have to be numbers. S&B, you love how we're a stream and a half into learning F# and we already have 2 recursive functions. That is because this kind of thing is so key to functional programming. Because instead of messing about with loops and with state, we can do it. We can use a recursive function, and you know, if we use something called tail recursion, we can get really good performance out of it. Not bothering with that at the moment. Not bothering with the optimizations. I don't think that always. No, these won't optimize. Actually, one will, one won't. Yeah, Fuel Snable, it's very appealing symmetry. We can construct and destruct using the same syntax. I mean, that is pretty lovely, and I wish I would remember that more often. But that's how lists work. So, actually, that add is named really badly. It's now sum and sum nums. So, because this requires nothing, let's see what this function does without having to mess about with anything else. So we've selected it, used alt enter to get it into interactive, and we have sum, which is a function that takes a list of float of numbers. So float list, I prefer if it was list float. Unfortunately, that's not my choice. And spits out a float. So let's make some use of it. So let's say that we're going to sum up the numbers, seeing as we've used them all along. 1.0, 2.0, 3.0, and you know, just to really surprise everyone, let's go for 4.0 as well. That comes back with 10. So what has that done? The first time round, it caught that case. It said we've got a list of nums and nums, and it took the 1. So it's returned 1 plus that sum of nums. In fact, what we're going to do is quickly let this print out what it's doing. So printfn, and then do that. So found list num is a floating point value, and nums is something that we can't represent as a primitive. So that's a %a. Nums. Okay, in this case, let's just print out something a little bit different. Let's go for a list of only one value. So found list of 1. And that's just a single number. And this one, let's just say, found the empty list. Found the empty list. Which will remind it it's denoted with that. And then again, we'll spit out a 0. So this now should tell us exactly what we're doing at any point. If we select the whole thing, Alt Enter to get it back in there, and we try our sum of the same numbers. It says we found a list, num is 1, nums is 2, 3 and 4. Then we found a list, num is 2, nums is 3 and 4. Then we found a list, num is 3, nums is 4. Then we found a list of 1, which is 4, and spit out 10. So, is it worth working out, trying to see what this does on the way back up the stack? Because this is on its way down. So once it's found a list of 1, spits out that num, and then comes back to here. So it unwinds, and this is the summation. So we can't really do a sum so far. Because we're not holding state. And this is another thing with functional programming. We don't hold state. Now this pattern is incredibly common. To do subtract, let's say, or multiply, so if we want the product, let's write that function, and I am going to show you something that's a bit not nice. So, product, what are we doing? We're going to change, and take notes on this to some degree, we're going to change two things. We're going to change the name. We're going to change three things. We're going to change the 0 value, because anything multiplied by an empty list we want to be the same, so that's multiplying by 1. And we have, instead of adding them, we use the star for multiply. Now if I send that to interact and go with the same again, but instead of using the sum of them, let's have the product of them. Let's say we're multiplying 1 to we also need to remember that we're not adding them there. Yes, thank you for the catch, S&B. That needs to be the product as well, because it's a recursive function. So put that back into interactive. In fact, that's there correctly. So if we do the product, that is 1 times 2 times 3 times 4. 3 4s, 12 times 2, 24 times 1, 24 still. So that should be 24. Would we agree with that? F# Interactive does. What have we done? We've done very little change, and I nearly forgot, and I forgot one of the changes. S&B had to remind me. So this is error prone, and this is a very common thing to do. So let's rewrite our add function for a second, because we had a very simple function that we've just made very complicated. Yeah, actually, Fuel Snable said you can ditch the single num case, and let's show how that works, because you really can. Let's ditch that case in both of these, and I'll show you why Fuel Snable would do it. Hi Statue.net, just copying some notes from the Visual Studio chat. By the way, if anyone's in the Visual Studio chat, I'm not looking at that, so if you can come across to twitch.tv/GarethHubble, I am watching the chat there. If we hate semicolons, we can do 1.4, and if you want even numbers, yeah, you can step. Yeah, you can decompose with double colons outside of a match as well. For Statue.net and for anyone else as well, if you want to join our Discord, where we discuss these streams and look at where we're going next, please feel free. That's the link. we do these beginner streams on a Friday. We do more advanced streams where we're actually building a product that we're going to be using on stream, hopefully from our next stream. We do that on a Tuesday and a Sunday. This is just a little bit of a wind down stream for me, a bit of a a more back to basics stream, making sure that everyone's up to scratch with F#. So yes, Fuel Snable has dropped that single number case. Let's see what happens if you do that. So let's put those there. And then let's try some of that list. Let's try the product of that list again. And what we find is it finds lists. So the first 3 lines are the same. But then we find a list where num is a single value and nums is the empty list. Ah, now the empty list is there for a good reason. So that's another reason to have the empty list case, is we can reduce down to that. Reduce is a good word to use at this point, I think, and we'll probably use that more. Now what we can't... We've got all this debugging information. We don't really need that, do we? We've got to that point. Oh, and by the way, just to prove the point, sum works exactly the same way. And gives us 10. So we know what we're getting. We know that it's taking a value off the list each time and then adding them all in that function, or multiplying them. All we've done is change the name of the function, meh, whatever. We've changed what the function does at its DPS level and what happens when we get the empty list. So if we take these printfns out, because we've got to the point where we understand them, I think, we've got a function that's not too big. But again, they are both following exactly the same pattern. Do you really want to do that? I'm not convinced that you do. Let's see about writing a function that does all this, and we just have to give it... We have to give it that value and what we're doing there. And let's call it reduce. So let rec, because we know this is recursive, reduce. That's going to take a 0 value, not an arrow, a 0 value, which is what happens when we get the empty list. It's going to take a function, so let's call it func. This is what we do, and it's going to take the numbers. In fact, let's just let it take a list of items, because there's no reason this has to be numbers. So what do we do inside here? Well, we're matching our items with the following. If the items is an empty list, then we return the 0 value that we gave it. We return the unique value, the 0 value, whichever you want to call it. If items isn't an empty list, it must have, and this is where we use the notation of x, double colon, x's, item, items, x's. And then it means we're going to do, well, we're going to reduce with that 0 and that func again, and x's, and we're going to do something with that function as well. So let's say we do, well, we've got a func, haven't we? So let's do func, which takes the 2 parameters of the x and that whole thing. So what do we have there? We have a function that is a little bit bonkers to look at. So let's go this slowly. We're saying that we are reducing, so we're reducing from a large collection down to a small collection. We want a 0 in there. We want a value to use in the event that we have an empty list. We want a function to do something with, and we want some items. Now we remember partial application, don't we? We really do. This is a higher order function S&B, yes, because it takes a function. Any function that either takes or returns a function is classed as a higher order function. Let's put this into practice, because at the moment all this A's, B's, it's a little bit confusing. Let's use something that's simple and see if we got this right. So let's have another sum function. Let's sum tick. Again, remember that single quote is allowed in definitions in F#, and we traditionally just use it to be an alternative. And this is not recursive. This doesn't need to be recursive. And we're saying that the summing function is we're reducing to 0.0 with a function. Now what's the function? Fun of A and B goes to A plus B. And we have a bit of an error. If plus has no mutable arguments partially applied, then the lambda can be removed. We're not going to bother with that at the moment because we're not going to use that for long. And that does a float list to a float. Let's put that line and let's have another go. Let's go sum tick of 1.0, 2.0, 3.0 and 4.0. And I am hoping that this doesn't go bang and that this returns 10. 1 plus 2 being 3, plus 3 being 6, plus 4 being 10. And if I remember my double semicolons, it does. Okay, that's cool. We have that. Hang on, this was our original add function, wasn't it? Why don't we pull that out and give it a name? We've already had this function before. So let add A, B becoming A plus B. And we've already agreed that that's a float to a float to a float because we're using it down here anyway. But now, instead of that, we can just say add. That is the reduce function. Now, that's something that's done really commonly in F#. So why do we even need to bother writing the reduce function? Now that we know what it does and how it works, I'm going to get rid of it. And inside the list module, we have functions. Do we have one just called reduce? We do. And let's see what that takes. That takes a reduction and a list. Why do you not take the other thing I was thinking of? Perhaps I should add some printfs and run it in interactive. Do you know what? Let's do that. So let's remember our printf ends again. Just to prove that this does exactly what I say it does. So empty list and printfn. See, this is why I'm so glad I've got people here who do know F# as well, so that you can help me teach this. So Fuel Snable, thank you. Found. And you know what? Now that we've got the idea of what that double colon does, we can just use that as a bit of a shortcut. So x's. So let's rerun interactive. Add is not defined, of course, with that. So we've got add, we've got reduce, and we've got sum tick that uses all of those. So let's go back up quite a bit and use sum tick. and double semicolon. So again, found one const onto the front of that lot. By the way, that is the cons operator. I don't know why I think it's Lisp related, but that's called cons. So that's one const onto the front of 2, 3, and 4. That's two const onto the front of 3 and 4. That's 3 const onto the front of 4. And that's 4 const onto the front of the empty list. So there we go. We've got reduce working. Now I could, because I'm a bit mean, let's say instead of doing that, let's use reduce directly. Because we never actually did a product to this, did we? Let's write the product one in here. What's the word for double semicolon? It is cons, C-O-N-S. That's in chat. If you look for that, if you look for a cons cells in Lisp, you get to see how lists are constructed in Lisp. I don't know if that's the same in C#, but it can be done that way in C#? F#. I don't know if it's done the same way in F#, but it can be treated as such. So we're reducing. What do we take? We take a 0. Well, our 0 we decided was 1.0 because anything multiplied by 1 is itself. And then the operation that we're giving, well, we're saying it's a function of A and B, and we're returning A times B. And that should give us 24. And it does, because the empty list there is treated as 1 there. So, does that make sense? This is, again, a pattern that is used over and over again, and it is called reduce. So, let's sum double tick, because I'd actually quite like to leave that in there. Fuel Snable, basically a list in F# is defined as type list is a list of, I was going to say that's going to be a list of T or empty, surely. It's going to be recursive. I would imagine that one of the cases would be a recursive. But let's sum double tick equal list dot. Now reduce doesn't seem to take what I think it should, because that isn't what I know as reduction. What I know as reduction, let's call it what F#'s calling it now, is fold. So list.fold, again, takes a function, a 0 value, and a list, and it spits something out. So we got this the wrong way around. If we use our reduce, if we now call it just fold, if we then suggest that that's fold there, and we reorder our parameters. So they are taking that, and that again needs to become fold. So, and those need to be the wrong way around again. So that fold has that function signature. List.fold somehow is a slightly different one. So I don't know where I'm doing things ever so slightly wrong, or slightly differently, should I say. Well, let's see if we can call it the same way in this instance. List.fold, add, and 0.0. And again, that takes a float list to a float. That takes a float list to a float. What happens if I put just a 0 there? Yeah, it doesn't. You can get it to do different types and whatever. We're not going into that yet. But that is the F# definition of of fold. Send that to interactive. We can send in, I'm sorry, Fuel Snable, I don't know what church numerals are, unfortunately. So if I send that sum double tick in, and instead of doing that reduce, we just do a sum double tick, we get the same value out. So what we've realised is F# does that fold for us. So we don't have to write that function. I'm actually gonna remove that because it's making things messy. So if people want to, they can catch up on the stream on the video on demand using, I think it'll be on YouTube in a couple of days, because I have an agreement with Twitch where I'm not allowed to not do that. I'm not allowed to put it up straight away. So sum, now we've worked out that instead of writing all of that code, we can just write a sum that does that. So we have the same issue with product. And if we remember our pattern, we're saying that the 0 is 1, because anything multiplied by 1 returns itself. And we are saying that the function is, we're doing a multiply. So let's give ourselves a multiply function to play with. Let multiply of A and B. Always remember, if you're going to use arguments, declare that. So A times B. Yeah, I did stick an extra space in there. That's saying it's all integers. That doesn't know any better yet. We will teach it that it's floats in a minute. And then our sum, our product function, now let product equal, well, what we're saying, that we're doing a multiply. So it's list.fold, because we're folding this list, we're reducing it down. We are using multiply to do it, and our 0 value is actually 1. The idea is that the value you put there, which we're calling our 0 value, is any value where that function that we pass in is called on anything, and that value returns the original value. So 3 times 1 returns 1. 4 times 1 returns 1. So that's why that returns 4, sorry. Hang on, let me do basic math. 3 times 1 is 3. 4 times 1 is 4. Anything times 1 is itself, as far as we care. I'm not going into infinities. For the addition, 0 plus 3 is 3, 0 plus 5 is 5, so that 0 is the 0 value. We don't need that product anymore, do we? So that's how using F# and using the fold function works, and that's roughly what we're doing. In fact, this calls them folder, state, and list. So folder is that. The state, the initial state that we're passing in, is that, also known as the identity element, as Fuel Stable has pointed out nicely for us. And then we pass a list in. Now, obviously, we haven't passed our list in there because we've partially applied it. So product is known to take a list and spit out a list. And the 1.0 there says it's floating point values. So let's have a look here. We can, at the moment, we still only take 2 numbers and we add them together. Let's use that sum though. So we're summing that list. This value is not a function and cannot be applied. Where am I going wrong there? Can I even do that? I probably can't, can I? Let list or let numbers. Let's do this. Equals a list of num1 and num2, and I know exactly where I've gone wrong there. Classic mistake, ladies and gentlemen, a very, very classic mistake of mine. I'm trying to apply num2 to num1 there. Semicolons delimit lists. Semicolons are vital. So we could do that. Some of those, well, let's just go numbers now. Yeah, for the C# in chat, fold is the same as enumerable.aggregate. And there's a very simple mapping between common link functions in C# and F#. Yeah, map, filter, collect, and fold. Yeah, they map extremely well to each other. In fact, link in C# is a supposedly scary functional concept that, because all the names have been changed, everyone seems to understand. Not getting into that right now, though, but yeah, you'll notice that link is from a functional concept. Async and await has its roots down there as well. In fact, link and the async await pattern in C#, as different as they look, really aren't that different, and F# can demonstrate that at some point. In fact, specifically, select many in link and the async await pattern are so similar in a lot of ways, but that's another show. So we're now calling some numbers, and numbers is our list, just to get us back on topic. So we can now come out of here, and we can run our program. SMB, the meaning of fold here is not exactly intuitive. You're guessing it has its origins in mathematics. I'm not sure. I know in Haskell there's fold left and fold right when it matters which way you do it. But the way I see it is I'm folding up that list, I'm folding a sequence up into one value. So I'm almost folding it side by side, almost like I haven't got the demo sheet of paper that I'd like to use here. But you know, we've got some paper. Let me quickly do this, because this is the way I try and think about it at times. So do excuse the slight noise you're hearing there. So I'm guessing you are. So I have that as a list potentially. Let me get to where I can see what I'm doing. So that's my list. Each of these panels is an item in it. I am folding those two together. Then I'm folding the next two. Then I'm folding the next two. Then the next two. Carry on folding, carry on folding, carry on folding. And oh look, we've gone from a list of panels to a single panel. So that's how I think about folds. And of course we've done it in that direction. There's nothing stopping us going in that direction. And that is the difference between fold left and fold right. So there we are. We spend money on this channel. We have really, really impressive visual aids. I'm glad that helped SMB. So that's how I think about it. Is you're folding the list onto itself. So we're in there. We're being asked for a number. 3. We're being asked for another number. 7. We get 10. So we haven't broke anything. Minxie Rose, makes sense and you get it now. Excellent, that's what we always try and do on this stream. Well, that and cough a lot apparently. However, we're doing this a couple of times. Why am I doing this multiple times? Does it really matter if I say another number? Can I just say please enter a number each time? And let's do something even nicer for people. Put those spaces there, and instead of using printfn, let's use printf. Yeah, we drink coffee on this stream too, Minx Heroes, and we do code on this stream. We do software development. So I've just taken the n off printfn. And now what we get is a different, a completely different idea. Oh, Fuel Snable, are we getting close to the unfold function? We're getting close to something a bit different. We're getting close to, I don't see why I should do this a million times. Is what we're really getting close to. So please enter a number, 3. Notice how that's now on the same line. Please enter a number. 3. No, I don't understand that. Let's go for 6. And it gives us 9. But we have just written a function that can take a list of numbers, any amount of numbers that we want, and we're only giving it 2. That seems a little silly to me. Shall we do something a bit different? Shall we grab ourselves a list of numbers off the user? I think we should. So, let's write a function, because we like functions in functional programming, believe it or not. Let's and go on. I'll spoil it now and I'll say that this is recursive. Ask user for numbers equals. Well, let's have a look at what we can do. We can ask for a number. Okay. We're trying to get a floating point value. Now at this point, we need to offer the user an option of getting out of this. So we've got quite an amount of refactoring to do. Let's show you what happens if we don't allow the user the get out of jail free card first though. So we're letting our number equal ask for float, please enter a number. And then what we're saying is we want to return. In fact, let's let that take a list so far. Numbers so far. And then we'll have a look at tidying this up, because it will need it. And then what we're going to say is we're going to carry on asking the user for numbers with our number constant to the front of numbers so far. So give the brackets there. So what we're saying is it's a float list to an A. And then what does that return? Ah, that's not returning anything. So let's return, just for giggles, numbers so far. In fact, let's throw an exception. Let's prove something. Let's go. Raise. Fail with. Choose fail with. So if I'm wrong, this will come up with something saying, we got here. Why? And then instead of asking for a float, we're going to ask the users, we're going to let the numbers equal something else. We're going to say that we're going to ask the user for some numbers. And we're going to pass an empty list in to start with. That printfn's never going to work. So let's show some of the dangers of recursion by running this program. Let's go into there. And let's see why this goes wrong. If anyone, apart from FuelSnable, who already knows this, I am convinced that FuelSnable knows this because FuelSnable knows way more F# than I have learned in a long time. If any of our beginners in chat think that they know why this is going to do something that you don't want it to do, please let me know now. See if we can get it in chat. So it's asking for numbers. So I'm going to enter a 3. I'm going to enter a 7. Let's have a 2. Let's have a 3. Have a finished. Please do something. What we've done there is put ourselves in an infinite loop. We have no way of getting out of this apart from, if anyone has run this, Control D. No, sorry, Control C. Please let me out. Please. I'm going to just chuck this terminal in the bin. That worked. And the debugger killed. Excellent. Why did we never get there? Well, what we did was we called askUser for numbers, which takes numbers so far. Minxie Rose is right, we haven't put an off switch in, we need an ignore type function. So we're going ask for a float, please enter a number. And that will always give us a floating point number, because that then recurses. But that recurses where if we give it the right answer, it returns. It only recurses, i.e. calls itself. So recursion is where you call yourself. It only recurses if something goes slightly wrong. It then bails out if you go right. Now here we've got no condition around this, so we're asking for a float. We get a floating point number back. We shove it on the front of numbers so far, and then we ask the user for more numbers. So that calls into there with numbers so far and gets a number off the user. Conjures it onto the front of that list and then says we want more numbers. At no point during this do we give the user the option to bail out of this function. So, when dealing with recursion, it is important that you always consider your way out of it. And what we're going to do here is we're going to change this from just returning a float to returning something else. We're at 2 hours into the stream. I think we've got time to do something like this quickly. And then I think we'll get to where Fuel Stable wants to go next time, along with why going that way is clever. But anyway, let's suggest that we need to have something else. So this returns a float at the moment. I don't think it should. I think it should return either a float or nothing. So let's do that. Let's say if text input equals, let's suggest that we put an N there, saying that the user doesn't want to, they're going to go no, N. Then we'll return that none that we saw earlier. Otherwise, we're going to do this whole match expression there. What's gone wrong there? Because I forgot to put the then in. So what we're saying is if text input is N, then we bail out with a none. Otherwise, we do that match. And of course, that value now, we need the other side of the option. Let's go into our sketchpad and have a look at why that's moaning. But let's screen sketch this. Lean over and grab the magic tablet, which actually fits on the desk today. Excellent. And the pen. So the question is, why can't we just return that float? I said I want to return none or a float. Well, what we're doing is we're returning a type called option. And that is defined as either being some A or some something, or a nothing, none. And if you remember, like I said about match, if is an expression in F#. So this whole thing is a single expression with a return value. The return value of the if is either that none or the return value of that match expression. Now that none is of type option. So this match expression has to return an option as well. Otherwise, we've got a problem whereby that if doesn't know what it's returning. So instead of that being a value, we have to wrap that up in a sum. Now some value, now that's an option type. That is definitely an option type. So we've got none, which we've seen as an option type, and some value is also an option type. So that's decided what we've got to do. We've got to wrap that value up in sum. And true to form, that is exactly how it's done. So now we are getting a list of float options. This could be a problem. Well, it's not going to be one yet, because we're not doing anything with them. However, if I were going to try and sum them, I can't sum a rook of options. I have to sum a rook of floats. So let's have a look. Let's see. We're saying n is none or some value is a value. So let's do a match. We've got a sum or a none at this point, so let's match that num with, and again let's grab our cases. Some value is something and none is something else. That some value is, well, it's giving us numbers, so we want to carry on going, don't we? None goes to, well, we've got a list of some numbers now so far, haven't we? So we want to do that. So num shouldn't go on the front of that. That should be value, because that is the unwrapped value. And we are going to get to that fail with now. So let's kill that, because we want that to be the last expression in this function. Just for a note for C# programmers again, you're used to people saying statements. In F#, I can't think of any statements offhand. We are expressions and functions. So we've matched that. Again, that num is just that ask for float, so let's sub those in. Because that num was named badly, it was a number option. So now we've got our bailout clause. So we've got a match there that says we're either going to continue, or if the user says no, then bail out. So let's go or n if finished. Okay, so we've now got a float list to a float list. So we're calling this, we're getting the numbers, and then instead of printing out that, why not print out, for now, sum of %a is %f. So sum of, and that's a capital A. S and B, can we trap the empty string rather than n? Yes, we can trap the empty string. All we do is delete that n there, and it traps the empty string. We can do plenty of things like that. So, but I'm going for the n just because I want to explicitly trap something. Let me just check. Yeah, the stream's still running fine. Skipped frames none. Cool. So, sum of %a is that f. Hey, we have transcoding, people. Just a quick announcement. If you are struggling with this at 1080p, we are now at a position where you can drop your the rate on this stream. So Twitch has given us transcodes. Thank you very much, everyone, for supporting us. So we've got sum of something is something. So let's, instead of num1, num2, because they don't exist anymore, sum of numbers is some numbers. Let's have a run of it. Let's see what we get. So, we're running. Well, we're building. We're taking our time. Hopefully when we get a new machine to do this on, it will take less time. But this is going a lot slower than I was hoping. So, please enter in a number or an n if finished. So, let's have 12, 3, 7, 14, 16, and we're finished, and we get 52. So what have we done there? By the way, if we run it again, we're even trapping some errors. Let's have another go. Let's add 3, 5, 11, okay, 11, 0.0, 23.6, 7. Oh no, that's how the river's spelled. Hang on, let's try it again. 7. Oh, alright, you still don't understand me. Go on, 7. And that's your lot. 49.6. I haven't added those ones up in my head. I believe that that's right. So 7, 23.6, 11, 5 and 3 is 49.6. 3 and 5 to give 8, add 11 to give 19, add 23.6 to give 34.6. I'm not sure actually. 23.6, 30.6, 41.6, 49.6. Yeah, okay, it is right. I can't do adding up. I can't do an adding today. Cool. So we've got that. We're getting closer. We've got an adding machine now. However, look at all this mutation we've got around the place. And again, we've got essentially a pretty usable pattern. So we might be able to extract a pattern function out of there. We've got an if else with a match inside it. This is starting to look a little bit ugly. So what I'm suggesting is next time, because I think we're now late enough. Yeah, we're 10 past 8 over here. I don't want to blow everyone's brains too much. Next time we're going to have a look at what can we do here to make this function look more pleasant. Why is this function doing more than I would hope? Because it's now doing a lot of things. Anyway, this project will be put up and a link will go to it. That'll be from the Discord. This will be zip files again. Remember to do the unblocks. So right click, properties, unblock in Windows. I don't think in something like Mac OS you have to do it. I could be wrong. Again, in any distribution of Linux that you're running, you know better than I do. Remember again, everything that I've shown you tonight, everything we've done tonight is completely free. We're using all entirely free tools. We are not paying for any of this. We can use this for production systems. Microsoft don't mind us doing that. So we are in a really good position there. Sunday night at 6 PM, Tuesday night at 6 PM, we are carrying on work on Twitch Deck. Hopefully to have that functional to the point where I can replace the tool that I'm using now within a very short amount of time. Actually, this tool does a lot more than I thought it did. Either way, I'm still looking to replace it very quickly. Again, if you wish to subscribe, if you wish to drop bits, I now accept both. We are now Twitch affiliates. If anyone's got any ideas for emotes, any ideas for sub badges, please again join the Discord. The Discord link is going in chat. Follow me on Twitter as well. These are the best ways to get notifications about streams. The November the 2nd stream, which is a couple of Fridays away, it is a fortnight on Friday, is being moved to the 1st of November. I've got a pre-existing engagement that I forgot about when I set the stream calendar up. So on the 2nd of November, we're having no stream. We are having the Friday Fundamentals on a Thursday that week, where hopefully we can do more work on this calculator. So let me go and do follow some tradition, find someone to raid. Let's go to following. Let's see if there's any of my followers on there. Again, if anyone knows of a development stream that you would like to raid, please go and let me know in the chat. We'll have a look. Ideally, I want to raid people with as reasonably few viewers. I want to give people a good boost. Hello Biff, less sweary. Given the amount of development streams that there are on here, I'd like to try and raid a developer. Who is there? There's someone using Rust. There's someone using C++ 17 and DirectX 12. Oh, that's going to be complicated. That's going to be complicated stuff. That's going to be fun though. Let's have a look at Rust, as it's a language that I am learning now. So, just something different, something still with functional programming in. I'm just chatting to you guys while I'm looking in their chat. It looks like they're going to carry on for a short while. And they're doing... Oh, there's a match express on their stream as well, on their screen. So let's go and give a little raid out to them. Raid Museum. So, good night everyone. Again, Sunday night, Tuesday night, 6 o'clock, same time as this week. And then Friday again, we're back to fundamentals. Thank you so much for your support. And the raid's going in. Come with us. Come and have some fun.